I'm going to look at question 5 and 6, the last two on page 304, just to finish off the section 20.5. Now, no more graphs drawing, just sketches. I'm told that in question 5, here are the equations of a curve and a line. So this is clearly the curve. You can tell in a second why. There it goes, 3x squared, that's a curve, minus 5x plus 2. And this is the line, y equals x minus 1. Now remember, we're dealing with simultaneous equations, one quadratic, one linear, and that's what we've got here. It says, show that the line is a tangent to the curve, show that this line is a tangent to this curve that goes a little bit like that at the point where we have the solution 1, 0. In other words, if this line is a tangent, as in a previous video, then it will touch the curve at just one point, and I've got to try and prove that this point is 1, 0. So I'm looking for a single solution where x is 1 and y is 0. Okay, that's what I've got, and that's what that becomes. Well, in other words, by doing a substitution for x minus 1 for y, in other words, as before, put this right there, I could play around with a single equation, a quadratic in x squared, in x's rather, and then solve it. So let's go for it, shall we? So this should be okay. So if I put the majority on the left hand side, so that's this part here, and that equals y, in other words my x minus 1, and bring it all over to this side then. So I've got 3x squared minus 5x plus 2, subtract the x, you come over here, and add on the 1, you come over here, because it's minus over there, isn't it? And I've got a lovely quadratic equal to 0. Tidy up a little bit. 3x squared minus 5 minus 1 is minus 6x plus, well, 2 plus 1 is 3, and it's really, really beautiful. Look, if you factorize it, take 3's out, I've got 3 lots of x squared minus 2x plus 1 equals 0. And of course, if you divide both sides by 3, you end up with this, because nothing divided by 3 is still 0. It's a really, really easy equation. So if we work down here in the darker bit here, I think I've got one of these. X and x makes x squared. The only way to make 1 is 1 times 1, and they're both negative because minus 1 times minus 1 is plus 1, and minus 1x and minus 1x is minus 2x. Look, there's only one solution. This is a perfect square. In other words, I've got x minus 1 squared equals 0. One solution only. So what do we do? Just take this little part alone. I've got x minus 1 equals 0, therefore x equals 1. So there's your x value equal to 1. I just want to substitute it into here now. Change to blue. Y equals x minus 1, and therefore y equals 1 minus 1, which equals 0. So therefore I've got the coordinate xy equals 1, 0. I've proved I've got a 1 there and a 0 there, and that's really easy. You have to draw a single thing. The next one looks scary, but it looks like fun anyway. It says the graph shows a sketch of a curve, y equals 2x squared minus 5x plus 3, and the line y equals x plus 11. I'll draw you what's in the book. We've got something like this, alright, and I've got something like that. That's a straight line. That's quite good for freehand, I'm going to say so myself. And they've labelled this point A, they've labelled this point B, and we're told this curve has an equation of y equals 2x squared minus 5x plus 3. I'm told the linear equation is y equals x plus 11. Charming, that's all I have to say about that. Now, what I've got to do, and they cross the points A and B, so that's A and that's B right there. Show that the points A and B can be found using the quadratic equation. In other words, x squared minus 3x minus 4 equals 0. In other words, merge these two and somehow get to that. Somehow get to it. And hence find the coordinates of A and B. In other words, it's a simultaneous equation. I don't have to plot anything. I substitute this part, for example, into here and form a quadratic just involving x's only. solve for x, there's going to be two solutions for x and therefore two solutions for y, which is why there's 2 points of intersection at A and B. So that's what I'm expecting reading the question ahead in my mind. It says hence find the coordinates of A and B. Yeah, there's two sets of solutions, two x values, two y values. Now, because this is likely to be a difficult affair, they've actually given us the answer we're aiming for. It says show that the points A and B can be found using this quadratic equation. Well, even if I can't get to that in an exam, I can at least use it to factorise a very, very simple looking grade B quadratic, alright? If I can't arrive at this point, I can at least use it and get 2 marks for the solutions for A and B. But let's try and get all the marks. Right, let's shove that in there. I'd rather write this on the right hand side first because it's there's less to do later. So that minus 5x plus 3 equals y, which is x plus 11. Now they're equal because this curve equals that linear graph because they will cross at 2 points, and these are the 2 points where these two graphs are equal. If I pointed just there and just then, I said, what's the equation of the line where that point is sitting? You can't tell me. Well, you can, but your answer will be, well, you're sitting on the curve, 2x squared minus 5x plus 3, and you're sitting on the straight line, x plus 11. So the answer is both, sir, and the answer is correct. It is both. So that's why we're going to solve this little animal and get a solution for the A and the B. Right, so x come over and get minused, 11 come over and get minused as well because they're both positive. So 2x squared minus 5x plus 3 minus x minus 7 equals nothing at all. 2x squared is on its own, minus 5 minus 1 is minus 6x, and that's meant to be 3, isn't it? Yeah, 3 minus 11 is minus something, minus 8 equals 0. Now I can factorise that, I can see that. So x squared minus, don't get glitchy, that'll be 3x because 3 2's make 6. And factorise that as well, get the 2 out of that one, that would be minus 4. And that equals 0. Again, if I divide both sides by 2, I'm going to get x squared minus 3x minus 4 equals 0. So I've actually arrived at what they said. Now I can go and factorise it. Let's stand out in green, hopefully. And yeah, there's going to be 2 solutions. Therefore, I'll get my 2 brackets ready. X times x makes x squared. I reckon 4 and 1 make 4 if you multiply them together. Now, in order to get minus 4, I'm going to need plus 1 times minus 4, and plus 1 add minus 4 makes minus 3. I will get minus 3x's. You sort that out for yourself. You're big enough now, got loads of experience of quadratics, going back from Unit 2 onwards. Make that x look more pretty if I possibly can. Yeah, here are the 2 solutions. So I've got, that's not very clear, let's go back to yellow or something, green, I don't know. I've got x plus 1 equals 0, therefore x equals minus 1, one solution. I've got x minus 4 equals 0, so x equals 4, second solution. Now let's work out their corresponding y's. I have to come up here because I've run out of space. So here I go. When x equals minus 1, y equals minus 1 plus 11. Look, it's right there, can you see? So minus 1 plus 11 equals 10. So the coordinate for A, let's just do one at a time anyway, and when x equals 4, y equals 4, 4 plus 11, which is 15. So I've got 2 coordinates there. I've got the coordinate minus 1, 10, which is probably that one because it's lower down than that one, which is 4, 15. So I'm going for that one is going to be minus 1, comma 10. That's that combined with that. And oh, please. Minus 1, comma 10. Close it off. And this one's going to be 4 for x and 15. So I've combined the y of 15 and the x equals 4 there. So that's going to be 4, comma 15. and these are my two solutions. So, conclusion, A is minus 110 and B is 415. They're my two coordinates, they're my two solutions, and that is a really nice question. The only problem is the pen and the pad got all glitchy and stupid, like it does from time to time. But that's it. I'm going to look at the assessment, and that'll be the end of quadratics and simultaneous equations, probably forever. See you later, everyone.